So, Vanakkam. So, we will continue our lecture on engineering seismology. So, we have been discussing about the seismic microzonation studies done in India. Okay. So, we have discussed about the Jabalpur work, which was the first and foremost work where kickstart a microzonation in India. So, then we followed by, we have seen the Delhi microzonation, which was funded by the several agencies. Finally, as on today, the updated classical report on seismic microzonation Delhi are available. I also said that the seismic microzonation of Bangalore work has been completed as a example study, even though the Bangalore is in southern part of India and placed on seismic zone 2 as per Indian zonation map, but still we have done that systematically to demonstrate how the microzonation study has to be done. So, as I said that the Jabalpur was started before the Bangalore. So, only they could do some patchwork and finally publish a microzonation map, but the Delhi work was done after the Bangalore, where they have done systematic studies, okay, and improved the final map has been prepared. So, there are some other work which is parallelly done along with Bangalore or before. Those work we are going to discuss. Okay, so today class with the continuation of the yesterday class. So, the another work microzonation map published is the microzonation of Sikkim. Okay. So, the Sikkim is a state, as you know, that is what the state. So, the Delhi and Jabalpur basically is a city. Okay. So, in between the micro and macro zonation, because the study area is very large. So, what they have done here basically, they carried out a seismic hazard analysis, okay, by deterministic approach by considering the seismotectonic parameters in the region and the maximum credible earthquake. Okay. Then the site response study was carried out using the receiver function and generalized inversion technique considering the strong motion data. So, these people basically, this was done by the IIT Kharagpur. They set up a permanent seismic stations at a different part of Sikkim. They collected a data, they tried to use that data part of the study. So, that was the one the good way of accounting some earthquake which is happening during that period, I think. So, the microzonation map was prepared, okay, by integrating the site factors, okay, which was obtained from the micro tremor studies or something like that, and then geology and soil type, which was again obtained from the geology survey of India map, and then peak ground acceleration and resonance frequency. So, the peak ground acceleration has been estimated by considering the detailed seismic hazard analysis, which we will be discussing in the future classes. So, finally, they prepared a geohazard map, probabilistic seismic microzonation index map, where you can see that they given a PGA distribution which is useful for the design of building, and also they given a basically the amplification map and hazard index map, the high, low, medium, okay, so intermediate kind of classification also they are trying to establish in this work. So, this was actually work was started before Bangalore, but completed during my microzonation study. So, where we have been also involved in the suggesting and improvement of those work. So, based on that actually the microzonation map, okay, the final map has been prepared by taking into all the consideration which is discussed in the steps given by this. So, only thing this map since it is done for a state level, the accurate information gone, okay, with the micro level may not be so appreciable as expected in the microzonation details. Okay. So, where you can see the station and then the hazard level. Okay. So, the proposed existing station and then the hazard level, where there are some seismic stations are set up and monitored by the IIT Kharagpur on this state, okay, basically for the improvement and establishing the better earthquake zoning of the state, okay. So, which was also under a process. So, this was a map. This report also basically released by the Ministry of Earth Science. So, you can browse it like a seismic microzonation of Sikkim, Himalaya. Okay, you can also browse that. So, the another study which was again carried out for the microzonation of Guwahati. Okay, so, these countries consist like Guwahati is on northeast part again. So, where you can they consider all the aspect which we have discussed by the seismic microzonation of Delhi, okay, where geology, geomorphology, soil characteristics, site response amplification and liquefaction, and then finally integrated the hazard map. So, you can see the hazard index values given here. So, the very dark color is basically having the lower hazard index, the red color is having the higher hazard index. So, this hazard index depends upon the what is the weightage you assign for each microzonation parameter, such as a bedrock hazard value, the geology, geotechnical data and amplification, liquefaction, landslide and tsunami. Okay. So, based on the density of the data and the velocity what you obtain, you get these hazard values are similar. So, you can also see that the interpretation of this microzonation hazard value may not be same. For example, the Sikkim it is written hazard value of 0.5 and Guwahati it is written 0.5 and Delhi it is written 0.5. These 0.5 at different regions are mean different level of exposure. The 0.5 with respect to what is the lowest level, not the only 0.5 means it is so much hazardous. Such kind of things are there as the integrations are done with specific to the parameters responsible in the region. So, this work also has been revised several times and then done, and then the seismic microzonation of Guwahati maps also released by the Ministry of Earth Science. Okay, you can find that maps and related plots where you can get a book volume of report. Okay, so which is useful to for the design as well as the retrofitting the existing structures. So, the similar kind of microzonation kind of work, many people, as I told you, that start working on microzonation. So, this is some of the work in the northeast, Das et al. So, like Central Water Power Research Institute, okay, so CWPRS, okay, so and IIT Kanpur. Okay, so they carried out a detailed study and then they prepared a map of 0.5 grid size, and then something was there, and then they prepared as seismic hazard analysis map 50% confidence interval and given a PGA distribution map, okay, by considering the all the seismic activities. Okay, you can see the different seismic zone and they included and then given a PGA distribution map. You can see the for the entire northeast region. Okay. So, even the Parvez et al. Also done some studies and then he also produced a map, okay, so which is also integrated. So, but here you can see that entire northeast region has been clubbed as a one entity they try to do. So, here they stopped basically seismic hazard analysis. Okay, they stopped with the seismic hazard analysis, which is a part of zonation but not a complete microzonation. Okay. So, that one has to remember when you refer this kind of publication. Okay. So, the another work, as I told you, that Mumbai people have done hazard analysis. So, basically the probabilistic and deterministic hazard analysis has been carried out. Try to people get a hazard curve, okay, which includes basically a bedrock seismic hazard value and then consider a soil, okay, the soil thickness in the region as a site class. Okay, so that is some kind of concept where it comes on the site characterization and then estimate a surface hazard. So, where the waves are considering the soil in the region. So, that they produce a different hazard curves. Okay, we will discuss about the hazard curve and then the uniform hazard spectrum during the probabilistic seismic hazard analysis. So, they estimated that and given for a different sites of the Mumbai. So, this is basically maybe the up to the step 3, okay, bedrock level assessment, soil data. Here actually people have collected a soil data or assumed a classification as it may present at some of the location. Okay, then they estimate a amplification using a empirical method. Okay. So, then they produced this kind of map which it claimed as a seismic hazard analysis of the Mumbai city. So, the another work which is done by the Dehradun Waldia Institute of Technology. So, where the a number of student, okay, the PhD student worked on different topic. Okay. Then finally, all these values are clubbed together and produced as a microzonation work. So the Dehradun, okay, so the Waldia Institute of Technology, so Dr. Mahajan, right now he is working on the other institute. So he was one of the pioneer, okay, person in MSW survey in India. Okay, he is the first one to carry out seismic surface wave testing in India and published a paper based on that, okay, which was one of the classical work we can quote here. So where some of the students are extensively involved on different aspect of the microzonation. Finally, they produce a microzonation map. So the Anusha Baru 2005, Raju Ranjan and Brijesh Guhalti. So those are all the people who are worked with Mahajan, okay, when he was in Waldia Institute of Technology. So this microzonation work was basically initiated by the International Institute for the Geo-Information Science and Earth Observation, okay, Netherlands, the Indian Institute of Remote Sensing and National Remote Sensing Agency, NRSA. Then the Anusha carried out database, okay, for the conduct lithology, tectonic, landform, associated neotectonics, regional scale and subsurface information, and then they tried to produce spectral acceleration map of Dehradun at a 10 Hz frequency. So you can see the spectral acceleration values corresponding to 10 Hz, 0.01 second basically. Okay, you can see how much the SA spectral acceleration values they have mapped. Okay, so then the Raju and Ranjan did the extensive MSW study and used cytospan's package called SHAKE. Okay, the SHAKE is a commercial program available to estimate a amplification. So then he tried to get a amplification at a different level of the Dehradun city. Okay. So where he tried to map the variation of the shear wave velocity, variation of the spectral acceleration for the Dehradun. So further the Brijesh Guhalti, where he taken the earthquake risk assessment of the Dehradun using the ASAS program. Okay, this is ASAS. So is basically a program which is developed by the FEMA. Okay, so USA. So this program basically, if we give the building stack, so and then the rock level PG and all, where you can try to get the vulnerability index of the building. So this is depends upon the building. You can see the building, different building type. So then the different utility of the building, residential, commercial, education, religious, government. So all those things, and then how much the damage you can expect. So this is the study carried out of the Brijesh 2006. Okay, where your vulnerability assessment study has been done. Okay, so this patch up the work differently done, but at the end the combining all of them and releasing a zonation map and risk map. Okay, I think it's not done as per my knowledge. Maybe we have to check. But this was done part of that institute collaborated with the other institute. It's not a initiation by the MOS, but as I told you that this is the classical work done by the first time, particularly on the mapping of shear wave velocity, measurement of shear wave velocity, and then running the cytospace analysis using the SHAKE. So that was a classical Raju Ranjan work which is guided by the professor from Waldia Institute of Technology, Mahajan. Okay, right. Presently he is, I think, affiliated to the other institute. Okay. So this is about the microzonation initiation for the Dehradun. Okay. So the similar kind of studies people have, as I told that, so with funding or without funding, there are a lot of work parallelly carried out by the different people. Okay, to try to say that whatever work they have done, they call it as a microzonation, irrespective of the number of component involved. Even I told you that people do the microtremor study and call it as a microzonation, do hazard analysis, call it as a microzonation, do VS measurement and map a VS map measurement, call it as a microzonation, do liquefaction mapping and call it as a microzonation. Even though I said that the integrating of all of them at the proper weights and ranks depends upon the region and producing a final map in terms of hazard index value, that is the final microzonation map. The first order microzonation map of Aldia was presented by the Mohanty and Walling 2008, The final map was generated considering the three themes like peak ground acceleration and the predominant frequency and elevation map. You can see that they consider PGA, which is like take care of the seismic hazard analysis, and then predominant frequency, some extent take care of the soil, and a elevation map. This is also again a soil which is indirectly amplification. Okay, amplification. So, this is the PGA must be prepared by considering the tectonic framework, past seismicity, and 5 seismic source zones around LDA. So, they are delineated the different 5 zones which they are expected. So, site specific predominant frequency is estimated by employing the national horizontal to vertical ratio of the technique given by this one. This is like micro tremor studies. LDA overlines a Bengal delta and the elevation of the region given estimate of thickness of the alluvial in the region. Okay. So, this is the hazard value prepared by the Mohanty by considering the whatever 3 parameter we discussed earlier. The elevation map LDA was obtained by analyzing the shuttle radar topography mission, the data assessed from the global land cover facilities. Then the figure shows the first order seismic microzonation map of LDA. As we have seen that the macro level map, which is like level 1, level 2, level 3 as per international recommendation. So, considering the geology and seismicity can be considered as a level 1, this one, that is why they call it as a microzonation level work. So, they given like low, okay, moderate, high and very high. You can see the color pattern. The darker color basically is the high hazard regions. So, even though they claim that it is a river deposit, okay, but there is no liquefaction analysis gone into the hazard mapping of this one. So, I am not very sure, I expect that this region may also get a liquefaction possibilities. Okay. So, but it was not published as a liquefaction included map for this particular region. Okay. So, similarly the seismic migration of the Talsir basin was done. So, the Talsir basin the given the dimension is given, it is in Orissa. So, where the isolated basin around here, this one the major tectonic structure Talsir basin has been reviewed. So, Mohanty et al given the multiple information, particularly generated a synthetic ground motion of the Talsir basin, and then they used like finite element simulation and scenario earthquake magnitude of 6 and focal depth of 5 km along the North Orissa boundary fault was used to simulate peak acceleration A max along the each profile. The response spectrum ratio, okay, so RSR, the function of frequency was computed. 8 profile, author have found that higher amplification associated with the thicker sedimentary cover. So, with that, okay, so they publish here this one, this you can see in the fault and associated this one, okay, you can see. So, the Talsir basin is subdivided to 3, zone 1 which is like the RSR is so much, zone 2 RSR so much. So, the value based scenario at Mohanty has highlighted that proposed seismic zonation Talsir basin correspond to the 1 degree variation of the macro intensity scale. So, this is actually macro level and they only consider again 3 parameters, okay, they did not talk about the liquefaction and other things, the basin generally which is associated with that. Okay. So, they given like low, intermediate and high. So, there are as I told you that there are many other people who carried out a microzonation component study and claimed as a microzonation of that particular place or a city. So, one of them like Mandal Parvez, okay, so Madhukar, Trivedi, Mohanty are working on Bhuj, Kutch and Ahmedabad, and people try to estimate a H/V ratio and then mapping at that predominant frequency, they also call it as a microzonation. Okay. So, the Mandal estimated the Kutch region using H/V ratio. Parvez Madhulkar presented a preliminary result of the site effect shear wave velocity subsurface soil using the microtremor array at 20 different sites of Ahmedabad, and this kind of results they produce and map the predominant frequency. This is actually a predominant frequency at a different location. Then they map. So, mapping of this will help you to understand how the geological formation, thickness of the soil varies at a particular steady region wherever you study. Okay. So, similarly the microzonation work also carried out by the Chennai city, which was carried out basically the IIT Madras Professor Bhuminathan and its group. Okay. So, then even some other people also carried out microzonation of Kochi, okay, where the SES and then Trivedi carried out microtremor studies. Okay. So, then finally these are all the people, they produce independently the report as well as the publications. Okay. So, the systematic integration of the hazard, which is published only for the few cities in India right now. So, you can say like the Guwahati and Delhi, okay. So, then the Bangalore, okay, as a city. So, as a state you can say that Sikkim. So, there may be large number of publication might have come from each microzonation component of the work or microzonation work, but the systematic hazard index value which consider all the parameters or all the earthquake hazard effect in the particular locations are very important. So, in this time I need to also highlight that there are several microzonation studies in the world. Okay. So, like this Turkey, Istanbul, Thessaloniki and then Italy, okay, then Japan, Mexico, San Francisco. So, these are all the some of the classical work where the piece and bit of work has been done at different places and published as a microzonation work. So, I think the Thessaloniki work is one of the composite work, okay. So, where they integrated all the possible different hazard parameters into that. The second is Istanbul, okay. So, that is also one of the classical work. So, where they try to basically delineate the area which higher and lower seismic hazard index or seismic risk, where you can facilitate or you can locate, okay, solid waste landfill, nuclear power plant and large dams in the low seismic region. That was one of the major objective of doing this seismic microzonation. So, if you have done a seismic microzonation, you can delineate a area, okay, and then you can try to avoid high risk area to place any of the important facilities. So, as I said that, so the people here and there collected a grant from different ministries and then the state level or central level, and then they try to generate a hazard values and then microzonation map as they think. So, generally the seismologist, geologist, they more concentrate on the H/V ratio. The geotechnical engineers more concentrate on the amplification ratio. The structural engineer more concentrate on the PGA response spectrum kind of things. Okay. So, but we have seen that the microzonation is basically synchronizing all the possible hazard. Okay. Again I will recap the different hazard what we consider. So, all the possible hazard means first the direct ground shaking hazard which comes from the hazard analysis at bedrock level, then characterize the soil and then understand how the soil thickness varies at a particular city, and then how it is modify the seismic wave, how it is potential to fail due to the liquefaction. Okay, that is the second part. Third, estimate the amplification by integrating the hazard bedrock values and the soil data collected at the step 2, and then produce a amplification map or amplified ground motion data at surface. Okay. Once you have done that, then you check that how the soils will undergo failure due to liquefaction, as you know the soil data collected earlier. So, then if you know the liquefaction possibility, so that is fine. If there is area is under a hilly terrain or hilly region, you should also need to consider the landslide possibilities, which is one of the major component in the hilly region. Then if the areas or cities are located close to the coast, you should consider also the tsunami possibilities and tsunami hazard map. Then you can integrate all this hazard appropriately with assigning the weights and ranks and get a hazard map. Okay. As and we have seen that even though there are many microzonation, if you Google it, seismic microzonation of Indian, okay, seismic microzonation in India, you can find plenty of papers which is systematically I mean listed by the Google, but the systematic microzonation map published was only applicable for the few cities like Delhi, Guwahati, Sikkim and Bangalore. So, Bangalore why I did not discuss. So, then the ministry felt that so when the change in the investigator and the institute and then depends upon their knowledge, so the microzonation has been claimed at a different level, not at a uniform level. So, then the Ministry of Earth Science taken a initiative basically to characterize the 30 important cities in the country and carry out a microzonation study. So, this was actually what they have done actually. So, the MOES mandated to provide country with the best possible service of weather and climate, ocean state and earthquake, tsunami, other phenomena related to earthquake system. So, hence they felt that publishing up the seismic hazard feature or hazard index or hazard zonation map also part of the MOES system, as it is under the IMD and where the lot of station has been maintained for recording the seismic data which we have seen there then. So, the ministry planned to take up seismic microzonation of urban accommodation, particularly 30 cities, okay, spread over the country with a scale of 1:25,000 or 50,000 in the during a 12-year plan. Okay. So, this was initiated in when 2013, okay, the part of 12-year plan. So, now basically they given, okay, some of the city they already started, it is undergoing. So, this seismic hazard microzonation is to be performed based on the hierarchical model of seismic microzonation with emphasis geology condition, ground condition mapping and then the amplification and liquefaction. So, this exercise involves generating multi-thematic map, okay, on the particular area and try to understand the soil properties and integrate with the seismic and geological data and try to get a liquefaction amplification of the particular location and finally produce hazard index map. Okay, that hazard index map will be should be the good. So, as I told you that, so in order to do the uniform microzonation, so the MOES, okay, National NCR, National Seismological Center, okay. So, what they did basically, they have taken a several cities, okay. Then they are basically doing the microtremor measurement by measuring the predominant frequency. Then they are drilling a borehole and getting a SPT N, okay, then VS measurement by the MSW and downhole survey. Okay, they finally all this data they systematically integrate with the bedrock level hazard estimation and give a microzonation map. Okay, so the zone 1, zone 3, zone 2, zone 4 like this on each city. So, presently the ongoing microzonation work is under process for the Mangalore, Coimbatore and Bhubaneswar. So, where I am also academically involved to microzonation of these cities. Okay. So, apart from that they also recently awarded 8 important city in the UP. Okay. So, those cities also where they adopt a similar kind of procedure. So, where now there is a guideline, okay, for how to do the microzonation, what are the parameter you should receive and what are the this one is. So, this was basically based on my PhD work, as I said, that microzonation of Bangalore city, okay, where we consider all the possible hazard and finally integrated all of them and produce a hazard index map of Bangalore, which was being done as to show the case study for the country. So, based on that only the MOES basically taken up this kind of microzonation studies. So, this is about a glimpse of microzonation studies done in India. So, by looking at all these things you can see that very systematic microzonation study are limited in the country, are available for the very few number of cities when compared to agglomeration in the entire India. So, we have cities with several crores of population, okay, but our microzonation studies are not available for all the cities. So, anyway the MOES now under the preparation of this kind of map. So, hopefully in the future we will end up in the good zonation map of each city. Okay. So, what is a good zonation map? We have seen the if somebody adopt a systematic procedures and discuss in the microzonation map and give a robust microzonation map at a particular location, that will be the more reliable microzonation map. Okay. So, with this we will close this class. Okay. So, apart from this kind of microzonation regional level, the world level also people do a macrozonation. Okay. So, the world community is interested in macrozonation and they produce lot of macrozonation maps, okay, frequently to the entire world and from data from the each individual countries, okay, and small big countries, and that global seismic hazard assessment or global seismic hazard model, okay, global earth hazard model, something like that they call. So, we will discuss about that, what was the status for India, okay, which work has been referred there and what was the mapping they produce, okay, so that you will differentiate what is the Indian microzonation studies and what is the studies carried out by other people, okay, on this angle. Okay. So, that we will be discussing in the next class. So, with this we will close today's lecture. So, we will move on to the next lecture in the next class. So, thank you very much for watching this video. I look forward meeting you in the next class.